Greetings, everybody. We are in Las Vegas at CES, and we're here with the CEO of Arch System. Andrew, welcome.
Yeah, great to be here, Lucian. Thanks.
All right, so Arch Systems, for those of you that may not recall from the December event, is a company that optimizes factory leveraging AI. So it's a platform, agentic AI, and I'll let you get into the details there. But before we get into the company, I'd like to understand a little better, when you were at Stanford, you did record-setting research. What from that experience still shapes how you think today about optimizing a factory?
Yeah, so I was, my academic background was in materials engineering, semiconductors. I built photoanodes and like a record-setting efficiency. I was using deposition and etch techniques, the same type that are used in a semiconductor fab. So in a way, when we first built the company, we went to a lot of semi-fabs and we said, okay, how is the same type of equipment being used to build chips out in factories? And then we expanded in SMT and injection molding and other areas, and actually in circuit board assembly is one of the biggest places that we work in today. But I would say from my background story, the non-glamorous part of my PhD was I was just constantly fixing my lab equipment. It was breaking all the time. I was switching pumps. I was tweaking sensor values. All of that was distracting me from what I wanted to do, which was optimize my product. I was trying to make my record-setting chip. And as it pertained to my chips, I was collecting just massive amounts of test data, and I was generating statistics and graphs and graphs and graphs. I spent all my time generating plots. And I would look at just hundreds of charts and use my head to try to figure out, what's happening. So the two things that influenced me from that, one was so much of my time got wasted from things that could have been more effective, maintenance, and that's kind of, we do a lot of that in making maintenance more effective. But what's more exciting, what we do at Arch, is helping people get to quality and compliance of what they're building. And that's about leveraging AI to understand, the data, all the test information, and just accelerate what you're doing. Right?
Thank you for those insights. Now, this week I heard the theme of moving from this digital transformation towards intelligent transformation. And edge optimization, for instance, delivers speed. The cloud delivers collective intelligence. How do you prevent one from cannibalizing the other? And in the future hybrid model, where's the one side? Is the one side going to inevitably win the other side?
In a way, I think it's silly that we're still having this edge versus cloud, but it's a good question because everybody's asking it, right? They're still like, is it all going to go to the edge? Is it all going to go to the cloud? Like, it's both, obviously, right? And so for anyone out there that's like still asking that question, it's like, first off, if it can be done in both places, it's way more cost effective to be done in the cloud. There's no question of security, right? Edge is not about security. So if it can be done in both, it will be done in the cloud. If it can only be done in one, it'll be done there. So there are some use cases where the latency is, millisecond, tens of milliseconds. That can't happen in the cloud. But anything that's at human speed, show up in 1 second, 5 seconds, 10 seconds, cloud transit time is fast enough. And when you talk about generative AI, that's now the biggest, you add up time, like collect data, send it, maybe you have, 1 second latency to go up to the cloud, but then maybe you're going to wait 10 seconds for your generative AI model to think and give you an answer. So that 10 seconds of waiting for the generative AI, like that's the long piece. And so, my view is it's both. Every organization needs a platform to collect and do things purely in the edge, and they need to be able to leverage these state-of-the-art AI models, especially the large language models, which often only have capabilities in the cloud.
Got it, thank you. Now, most optimization systems assume stable world. Factories live in constant disruption, energy volatility, material shortages, labor constraints. What does it take for optimization to actually keep up with reality?
Yeah, so if you take a step back, you think about how optimization has happened for a long time. It's been human-driven. And either companies would have a continuous improvement internal team, or they might work with Lean Six Sigma consultants, continuous improvement. And the classic thing is you bring a firm in once every 6 months or a year. And that made sense because your factory was largely pretty stable, and it just very occasionally got non-optimized. And then you'd bring in this SWAT team, and they would check everything out. They'd give you 3 big recommendations, save $1 million, $10 million, whatever it was, and leave. And then the factory would do its thing. And as you said, today, like product cycles are smaller than ever. Customer demand is changing constantly. Labor is changing. Suddenly this person leaves already. The new person needs new training. The equipment needs to be reconfigured. All kinds of stuff. You're changing how you're doing your floor plan. And so the need to do checking of your throughput and your quality and your, all that needs to be done literally in real time. So that is impossible to be done by people. And these things have really come together, right? It's not so much that it's just possible with technology, it's that the human way of auditing a whole factory and doing continuous improvement guidance is just too slow. You must have something that is completely dynamic in real time that can check at faster than human speed.
Got it. Now, we were talking about you work in various industries and optimize processes. What's the biggest blind spot yet, and perhaps what expensive mistake isn't showing up on a P&L?
That single biggest blind spot is a tough one because it is. I'll answer it. I'll give you one, but it is kind of a collection of things. Because the answer to that last question I just gave, which is that you can't have this continuous improvement team, parachute in once every 6 months, because it's happening constantly. It's kind of death by 1,000 cuts, right? It's like one day, maybe suddenly you have defects popping up that people haven't solved yet, and now they're causing tons of repair and scrap. Another day, you suddenly change the way you're doing changeovers, you're losing tons of change. Another day, a machine's starting to fail and you're not catching it yet, and you don't realize how much it's dragging you down, right? And so it really is death by 1,000 cuts. But the thing that's hidden on the P&L, since you asked that question, is on the P&L, you're gonna see how much revenue you're making, you're gonna see how much scrap you have, you're gonna see your repair cost, your labor costs. But what people are really struggling with in factories is they don't have enough expert indirect labor. They don't have the engineers, they don't have enough planners, right? They don't have enough of these technicians. And that would add more costs to the P&L. So it's kind of like, where is that on the P&L? What actually shows up, because for the same amount of CapEx, which is on the balance sheet, for the same amount of resources, the factory's not producing what it could. It's got a first pass yield of, say, 60%. It could be 95, right? It's got a utilization of 20%. It could be 80. You could 4x the utilization of that CapEx. And that would actually cause more expense on the P&L in terms of indirect labor, but people can't find it. And that's, again, it's a little hard to wrap your head around with AI, because you're like, what exactly does it just drop on the P&L? It's like, well, it will make your whole factory run fundamentally better by augmenting the labor that you can't get, right?
Got it. Now, you've touched on something very important. It's very complex. So with your expertise and your team's expertise in data science, what's the ultimate goal for a plant? Is it for a plant manager to ask the question in plain English, and how far are we from that? Or is it the system that builds and optimizes the logic for them? What's the goal for it?
So, if you go back, the early stage of IIoT, the ultimate goal was to connect stuff so you had real-time visibility instead of late. It was KPIs, but at least I see my KPIs today instead of in a month, right? Then in the machine learning era, the ultimate goal was to get predictive. Like, I don't want to be reactive, I want to be predictive. I want to know in advance that the machine's going to fail. Now we're in the generative AI era. The ultimate goal is for our technology to do a lot of the work for us, like completely closed loop in one mode, and then in guidance in the other, to have done some of the deep root causing and tell us what to do. So it's to get away from now statistics and KPIs, like back to my PhD example of like looking at tens or even hundreds of charts and data and spending all that time. Nobody has time for it. We're overflowed with data, nobody has time, and honestly the labor that you are getting, like sometimes they don't know what to look for. The people that do are so valuable, so busy, you don't want their head stuck in Excel all day. So the ultimate goal of generative AI is to act like indirect labor, to literally be in the factory, to wake up at the right time. Now as I need to solve a problem, there's suddenly defects, or I predict there's defects, and then I'm going to look through all the information, I'm going to understand it, and maybe I'm going to directly tweak a parameter, or at least I'm going to give guidance to someone that is super clear. Here's what you need to do.
Got it. Andrew, I want to close with one last question, which is, if you could optimize one thing for manufacturing, let's pick one of the verticals that we've referenced earlier, maybe it's automotive, maybe it's pharma, life science, whatever it might be, and one thing that manufacturing avoid because it's too political, what would that be?
Okay, too political. I mean, it's obvious what it is. It's what's too political right now? It's talking about labor automation with AI and where you build in the world, right? We're in a world where we're now post tariff era, and everyone's recognizing that you need manufacturing. Like, every country wants manufacturing. I'll speak for my country, the US. We want manufacturing here brought back to the US. What is actually happening right now, and I kind of blame management, is I need to tell two things to my board. I moved manufacturing back to X, America, India, Europe, whatever, and I'm using AI. Where should you be using AI? In your high-cost labor regions like the US. Will that create less jobs? Yes. Will we still create jobs? We will. We'll create more jobs by moving factories back to the US, but proportionally less. That's just true. It's kind of an uncomfortable truth, but it's just true. You know what's actually happening? Factories, management is moving, one line or one tiny factory to the US, celebrating in the papers, and then they're using AI in Asia where they need it less. Why? Because in Asian cultures, you say, use the AI, and they say, yep, and they use it right away. And so they go, we're using AI, and we moved a factory back to the US or Europe. But they haven't taken on the hard part. So if I could change one thing for companies, for large manufacturers, is that they would not hide from the hard, real work, which is to move, not all, but the right number of factories back to high-cost regions, like Europe and the US, and they would take on the change management battle to make AI work in those factories. And everyone would know, that's the real challenge. It will create less proportional jobs, but still good jobs. They would tackle that, and then, in terms of the news and the papers and everything, maybe you can help. We would really celebrate the people that have overcome that challenge and show that they've made it work in these cultures. And that's, again, it's kind of uncomfortable, but that's
Plus,
reality.
you're also adding jobs. It's not just the news. It isn't about bringing back the factory, but you're creating new jobs, making less than you would have 20 years ago when you moved into a low-cost area.
And just call it out. Yeah, this factory would have had 2,000 jobs. Now it has 1,000. But we brought 1,000 jobs back, and they're better jobs, and we're using AI to make ourselves competitive, right? Just call that out and make it work. That's actually the factory of the future that we want, right?
Andrew, thank you so much for insights and blunt conversation.
Yeah.
And good luck with the meetings today at CES.
Thanks, Lucian. Great to be here.
All right.